Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about sum of infinite geometric series. Look at this. We know that sum of geometric series is u1 1 minus r power n over 1 minus r. When n gets very large, if n gets very large, what happened to the sum situation, that is if modulus of r is greater than 1, the absolute value of r is greater than 1, then the series diverge, said to be divergent, said to be divergent. Now, other condition, that is then diverge and the sum becomes infinitely large, and sum become infinitely large. Then if minus 1 is greater than r is greater than minus 1 and lesser than 1, the words, that means r is lesser than 1, that is absolute value of r is lesser than 1, then r power n approaches to 0, for very large n. That means if n becomes very large, what happened, that one, this r approaches to 0. That means 1 divided by very big number, it becomes approaches to 0. Then therefore Sn, sum of series, will closer to becomes u1 over 1 minus r, because it becomes large, means it approaches 0, that is u1 into 1 minus 0, that is u1 over 1 minus r. Therefore S infinity, sum of infinity terms is u1 1 minus r is for r is lesser than 1. Therefore this is a sum of terms, infinity terms in geometric series is the formula. It's called a limiting sum. Now, for example, look at here. You have to consider that 0.3 recurring is equal 3 over 10 plus 3 over 10 squared is 100, 3 over 1000, like it's increasing. Now, which is an infinite series. Here, in this, un is 3 over 10 and common ratio is also 1 over 10, because 3 over 10 divided by 3 over 100 over 3 over 10 is here, or 3 over 10 over 3 over 100 over 3 over 10, which is equal 3 over 100 into 10 over 3, 1 by 10. Now, for example, we have to find 7.7 recurring in rational form. This is a recurring decimal. How to make a rational number? That means what? Fractional number equivalent to zero point 0.7 recurring. So we know that 0.7 is 7 over 10 plus 7 over 100 plus 7 over 1000, like it goes, where here r equal to 1 over 10. R equal to 1 over 10 and u1 initial term is 11 over 10. That is, we know that S infinity, sum of infinity terms, u1 over 1 minus r, which is equal, u1 is 7 over 10, 1 minus 1 over 10, which is equal 7 over 10. 1 minus 1 over 10 is 9 over 10, that is 10 over 9. So, therefore, 0.7 recurring is equal to 7 over 9. That means if you divide 7 over 9, we can get it 0.7777 recurring. Now, look at one more example. Find sigma k equal to 1 to infinity 3 over 4k. 4k. Then first we will expand this is equal 3 over 4 over 1 equal 3 over 4. Then we continue like, then 3 over 4 2, 3 over 4 3, like this. Here r, the common ratio r is second term 3 over 4 square into first term division multiplication reciprocal by 3 is 1 over 4. Here r is 1 over 4 and u1 first term is 3 over 4, 4 1 is 4. Then S infinity is u1 1 minus r over n over 1 minus r. S infinity, which gives this term becomes 1 approaches r4 and approaches 0. Therefore, you can write this as u1 over 1 minus r, which equal u1 is 3 over 4 minus 1 minus r is 1 over 4, which is equal 3 over 4. 1 minus quarter is 3 over 4, that is 4 over 3. Therefore, sum of infinity terms is equal 1. That means if you add up these numbers up to infinity terms, all the terms sum is 1. So far we discussed about infinite geometric series.